Good day to all the students. In this class, we see the 5.3 definition of importance terms related to coordination compounds. In this section, totally 7 terms. After see the 7 terms, you understand the concept and answer the self-evaluate section 2 is enough. Totally 5 questions. Now, for understanding purpose, I take one example and explain it. After that, you answer that self-evaluate question is enough. First point number 1. Outside. We take the one example. This is a certain notation. This is a structural formula. Both are same complex, coordination complex. Point number 1. Outside of this square bracket ion is called simple ion or counter ion or ionizable ion. Within the square bracket, this part is called coordination entity or coordination sphere or coordination complex ion. These ions, complex ion is called non-ionizable ions. In this square bracket part has 2 parts. First part is called central metal ion, denoted by M. Second part is Glicon, denoted by N. In this example, central metal ion is Fe, Glicon is Cn. Point number 2. Central metal ion Fe. This central metal ion also called Lewis acid because of this central metal ion lone pair acceptor. That is why this central metal ion also called Lewis acid. Third term, ligand is called Lewis base because of this ligand donate the electron pair to the central metal ion. Point number 4 is the coordination complex ion, already explained. Point number 5. Coordination polyhedron. The polyhedron means the 3-dimensional arrangement of this ligand makes the shape of the coordination complex. For example, in this example, you join these 6 ligands, makes the octahedral shape. Simply coordination polyhedron means the shape of the complex ion. In this example, shape of the complex ion is octahedral. point number term sixth is called coordination number. Coordination number also called the secondary valency. Coordination number means the number of ligand also donor atoms, the number of donor atoms. In this example, the number of ligands are 6. The coordination number therefore 6 in this complex. The ligand has, in this example, ligand has two atoms, carbon and nitrogen, in which carbon donates the lone pair to the central metal ion. Therefore, carbon atom is called donor atom. The number of donor atom is 6. 6 carbon or 6 donor atom. Therefore, coordination number is 6. Therefore, the coordination number is nothing but number of donor atom. 6 carbon. Therefore, coordination number is 6. Also, second definition for the coordination number is the number of coordinate covalent bond, which is sigma bond. Therefore, the coordination number is the number of coordinate covalent sigma bond. That is the number of coordinate covalent sigma bond mentioned like this. That is the ligand to metal coordinate covalent bond. In this example, totally 6 coordinate covalent bonds. 1, 2, 3, 4, 5, 6. This is also called the coordination number. The coordination number has two definitions. Number of donor atoms, that is 6 carbon atom, therefore coordination number is 6. Second definition, the number of coordinate covalent sigma bond, also 6, therefore coordination number is 6. Seventh term, oxidation number. The definition for the oxidation number is given in the book. Definition for the oxidation number: net charge on the coordination complex equal to oxidation state of the central metal ion plus number of ligands multiplied by charge on the ligands. For find out the oxidation number, we need first net charge on the complex ion. Number of ligand we can find out from the complex ion. The charge on the ligand, we know the sum of the ligand, its charge. Laterly, I mentioned that ligands and charges in types of ligands. Now, take the example to find out the oxidation number given in the book. First example 1. Net charge for in this complex -4 equal to the oxidation state of the central metal ion taken as X plus in this example, total number of ligands are 6. Put 6 minus 1 is the one ligand charge, that is Cn, cyanide has a 1 minus charge, therefore put the minus 1. Now for getting the oxidation number of the metal ion, this minus 6 goes this opposite part, we get the plus 6 minus 4 equal to plus 2. That is the oxidation state of the central metal ion. Second example, for this coordination complex, net charge is plus 2. Central metal ion oxidation state taken as X. The ammonia NH3 net charge, that is neutral ligand, therefore net charge is 0, totally 5 ligands, therefore put 5 plus 1 Cl. 1 Cl charge is minus 1. Now you can solve, this term will be cancel, this minus 1 comes to this side, get plus 1 plus 2, totally plus 3. Therefore the oxidation state of the central metal ion of cobalt is plus 3. Now we see the totally 7 terms. Next, types of the coordination complexes. Based on net charge of the complex ion, this is important for find out the oxidation number, also to naming the complex ion. Therefore, first complex ion, cationic complex ion, it carries the net positive charge. Example, in this complex ion, coordination complex ion, Cl is the simple ion. It has a negative charge. Therefore, the complex ion has a plus 1 net charge. Therefore, this is called cationic complex. Second example also, Cl, chloride, simple ion, has a minus 1. For charge on the ligand, we can use this periodic table. Based on the periodic table, we can find out the ligand's net charge. For in this periodic table, first 1s group, lithium, sodium, potassium, and this first group has a plus 1 charge. Second 2s group has the plus 2 charge. Likely this oxygen sulfur selenium group has the minus 2 charge. This is a 16th group elements. This is a halogens, that is simply halides has the minus 1 charges. Using this we can find out the net charge on the complex ion. In this example, 1Cl has a minus 1 charge. Therefore, for a balancing, complex ion has a plus 1 net charge. Therefore, cationic complex second anionic complex carries the minus 1, carries the negative charge. For this complex ion, potassium, we already seen potassium 1 plus potassium 1 ion has a plus 1 charge, totally 3 plus. Therefore, the complex, this square bracket complex ion minus minus 3. Therefore, anionic complex. Likely 1 sodium has a plus 1 charge, 2 sodium has a totally plus 2 charge. Therefore, this square bracket coordination complex has a minus 2. This is called the net charge, which is used for find out the oxidation state of the central metal ion. Third complex ion is called neutral complex ion, that is no net charge on the complex ion. For example, NiCO, it has in this complex the net charge is 0. Therefore, complex ion is a neutral, that is no net charge. Types of coordination complex using kinds of ligands in coordination entity, that is homolipidic, in which coordination complex has only one kind of ligand, that is ammonia, only the one type of ligand. Therefore, homolipidic coordination entity. Second is the heterolipidic, in which the coordination complex has more than one type of ligand. That is, in this case, there are ammonia is the one type of ligand, chloride is a second type of ligand. Therefore, this complex is called the heterolipidic complex. Next, types of ligands based on the net charge of the ligands. First, ligand has the positive charge. That ligand is called the cationic complex. Example, NO plus. Second type of ligand, anionic ligand. The ligand has the negative charge. For simplification, I put these ligands have a -1 charge, which is used for find out the oxidation number of the ligands X, that is chloride, bromide, iodide. These are simply -1 charge, like that cyanide -1 charge, hydroxide -1 charge, NO2 nitrate also has a -1 charge, nitride also has a -1 charge. -2 charge ligands are carbonates, sulfide, sulfate, oxalate. These ligands has a charge of -2. This is important for solving the oxidation number of the central metal ion. Also the neutral ligands, En ethylene diamine, carbonyl, EDTA, pyridine, H2O, triphenyl phosphine, ammonia. These ligands has zero charge, that is neutral ligands. Types of ligand based on the number of donor atoms, that is first monodendate ligands. These ligands has only one donor atom. Second, polydendate. Polydendate means these ligands has more than one donor atom. Bidendate means ethylene diamine and oxalate has the two donor atoms, which is asked in the 1 mark question. First example book back question. EDTA has a hexadendate ligand. This is used for find out the coordination number of the complex ion. Tri and tetradendate ligands. Hexadendate means it has a 6 donor atom. Tri and tetra means 3 and 4 donor atoms respectively. Now go to the self evaluate section question. In this complex ion, identify the following. First question, central metal ion or atom. The central metal ion in square bracket area, first part, this PT is called the central metal atom. Second question, ligands and their types. Third question, coordination entity. Coordination entity means and oxidation number of the central metal ion and coordination number. Now see the answer for this question. This is the complex ion. Identify the following. Central metal ion in this square bracket area is called the complex ion or coordination sphere, in which two part. First, this part is called central metal ion, PT. Others are called the ligands. The ligands are, therefore the ligands are NO2, H2O, NH3. This it has a 3 ligands, NO2, H2O, NH3. ligands and their types. In this question, the types of ligand does based on net charge. NO2 has a anionic, that is, it has a negative charge. H2O and NH3 is a neutral ligand, that is no net charge on these two ligands. Types of ligands based on the number of donor atoms. These three ligands are monodentate ligands, that is, these ligands, each ligand has one donor atom. Therefore, these ligands are monodentate based on the number of donor atoms. Third question. Coordination entity. Coordination entity means in this example, this square bracket area part is called the coordination entity. Therefore, you can write this square bracket area. Outside this Br is called simple ion or counter ion or ionizable ion. Br has a -1 charge. For balancing, -1 means for balancing +1. Therefore, we put the net charge on the complex ion is +1. Next, fourth question, oxidation number. We already mentioned that net charge is +1. Put the +1. The central metal ion oxidation number, put X. In this case, H2O and NH3, these two ligands are neutral ligand. Therefore, we can eliminate it. Net charge is 0. Remaining only one ligand, NO2, has a -1. That is one ligand multiplied by -1, we get the -1. Therefore, X -1 equal to +1. Therefore, X, this +1 comes to this side, -1 comes to this side, become a +1. Therefore, X equal to +2. That is, oxidation number of the central metal ion is +2. Coordination number. Coordination number has two definitions, that is number of donor atoms. In this case, nitrogen is a one donor atom, H2O is a one donor atom. In ammonia, two nitrogens are two donor atom. Therefore, 1 plus 1 plus 2. Therefore, totally 4 donor atoms. Therefore, coordination number is 4. Otherwise, also coordination number is the number of metal to ligand sigma. Metal to ligand coordinate covalent sigma bond also same 4. Therefore, coordination number is also 4. Thank you very much. In this section, once again we see the seven terms and this self-evaluate question. Thank you very much.